We're starting with lesson 93, and then we'll do lesson 94. And they're both pretty short. In fact, we end up doing like half of your check for understanding for 93, just to make sure that everybody feels good about it. So we're starting on page 907, and we're going to start breaking down an experiment and how exactly we divide up the people that go into our treatment groups and how we find those treatment groups. So this is called the language of experiments, and just like usual, we'll talk about this in context of an example. So 30 men and 30 women are subjects in an experiment to determine the effectiveness of the pain relievers Tylenol and Aleve. Subjects were either given 1, 2, or 3 tablets of one of the types of pain medication. So the first thing that we want to make sure that we understand is what's the explanatory variable, what's the response variable, and what are our experimental units. So the explanatory variable is the variable that the researcher controls. This is the variable that the researcher controls. They are controlling 2 things in this problem. They are controlling the pain medication, like the type of pain medication, but they are also controlling the amount of that medication. So there are 2 explanatory factors here: which pain medication they get and how much of that medication they get. Researchers are controlling those 2 things. The response variable is what we will measure or assess. I feel like that's too many S's. At the end of the experiment. So this is what we're hoping will change due to what we're controlling. So we're hoping that the headache pain changes. So our response variable here is headache pain. And then lastly, our experimental units, sometimes these are also referred to as subjects. So these are just the people that you are going to put into your treatment groups. So that is 30 men and 30 women. So that's the very basics of our experiment. We have an explanatory variable, we have a response variable, and we have our experimental units. Now we're going to add on some more descriptors of the explanatory variable. So often the explanatory variable is also called the factor or factors. So these are also referred to as factors. So in this case, we have 2 factors. One of them is pain medication. The other one is the amount. I decided to write that slightly differently. So we have to take these 2 factors and we have to organize them into our treatments for this experiment. The easiest way for me to do this is to draw a picture. So this one, though, is slightly easier to just list them out. If I just wanted to list out my treatment groups, they would look like this. So the options are my 30 men and my 30 women could have, so let's say, where do I want to put these? So I'm just going to write treatment groups. And I'm just listing them because I can easily see what they would be. So you could have 1 Aleve, 2 Aleve, or 3 Aleve. You could have 1 Tylenol, 2 Tylenol, 3 Tylenol. And one thing to note within this is that you can see both factors in the group. So 1 Aleve, that's 2 factors. 2 Aleve, that's 2 factors. So I end up getting 6 treatment groups. Typically, though, it's not quite as obvious to list them out as this problem has it. So I'm going to show you how to draw a visual of these treatment groups. So I'm going to, in this area, make a table of the treatments. So across the top, I'm going to write factor. This factor is going to be the pain medication. And this pain medication has 2 levels. This pain medication has 2 levels. One of them is Aleve. The other is Tylenol. Now, down the vertical side, I am going to write the other factor. So I'm going to flip my paper on its side. And I'm going to say factor. This time, the factor is the amount. This factor has 3 levels. This factor has 3 levels. So you could have 1 of these pills, 2 of these pills, or 3 of the pills. And now this table kind of works like a multiplication table. So you line up these 2 things. This would be 1 Aleve, 1 Tylenol, 2 Aleve, 2 Tylenol, 3 Aleve, 3 Tylenol. The boxes tell me how many treatment groups I have. So notice there's 1, 2, 3, 4, 5, 6 boxes. So there's 6 treatment groups. So now we know that a factor can have more than 1 level, and often does. The last thing that we could determine is how many experimental units go into each treatment group. So if we know that there are 30 men and we have 6 treatment groups that they need to be divided into, we know then that we have to put 5 men in each group. Well, we have the same amount of women. We have 30 women. So if I wanted to, I could go in and fill into each box. I'm going to have 5 men 5 women. 5M, 5W. And now with one picture, I can show my AP grader or whoever's looking at this how many treatment groups there are, how many factors there are, how many levels there are, and how many experimental units are in each treatment group. So this one little picture gives you a lot of information, and that's the language of your experiment. So the factors, the levels, the number of treatment groups, and the number of experimental units in each group. You're hanging in? Okay, let's look at another one. So next one is growing tomatoes. Very similar. Does adding fertilizer and using water affect the productivity of tomato plants? A gardener plants 24 similar tomato plants in identical pots in his greenhouse. He will add fertilizer to the soil in half of the pots. He will also water 8 of the plants with half a gallon, 8 with 1 gallon, and 8 with 1.5 gallons each day. At the end of the 3 months, he will record the total weight of the tomatoes produced on each plant. So in this case, our explanatory variables, there are 2. It is fertilizer and water. So we are controlling, do they get the fertilizer, yes or no, and how much water they get. That means we have 2 factors. In the problem where I know the experimental unit, the explanatory variable, it's the very first sentence. Does adding fertilizer and using water affect the productivity of your tomato plants? So that just means, does it have an effect on the tomatoes that are produced? Our response variable is given to us at the very end of the prompt. So it says, at the end of 3 months, he will record the total weight of the tomatoes produced on each plant. So your response variable is total weight of tomatoes produced on each plant. And then lastly, we have to determine what are the experimental units. Well, we applied fertilizer and watered 24 similar tomato plants. Now that we know these things, we can go through and figure out what are my levels, how many treatment groups do I have, and how many plants am I going to put in each treatment group. So just like I did before, I'm going to start a table, and my top part will be one of the factors. It doesn't matter which one you write first, so I'm just going to do the fertilizer. And these ones are the harder ones for me to tell, but there are 2 levels. There are 2 levels of fertilizer. Either the plant got the fertilizer, so yes, or it did not. So no. That's the first part of my table. My second factor, in fact, I'm wondering if I can just write it this way. My second factor is water. There were 3 levels of water. We watered them either a half a gallon, $1 gallon, or 1.5 gallons. And now I can clearly see how many treatment groups I have. So the boxes represent your treatment groups. So 1, 2, 3, 4, 5, 6 treatment groups. So one of those groups is fertilizer with half a gallon, fertilizer with 1 gallon, fertilizer with 1.5 gallons. No fertilizer half a gallon, no fertilizer a gallon, no fertilizer 1.5 gallons. Then we have 24 tomato plants that we need to divide into the 6 treatment groups. So that means we're going to put 4 plants per group. And sometimes I like to fill that in. So like on this one, I could just go in and fill in 4 to each group. Because I like to verify that what I have makes sense. So now what I know is that half of my tomato plants, so 12 of my tomato plants will have fertilizer, and then the other half won't. And then just like the prompt told me, and it didn't make sense when they told me, but now it does, 8 of my plants are going to get half a gallon of water. Well, if I look at the half a gallon row, 8 of them are getting half a gallon. 8 are getting a gallon, 8 are getting 1.5 gallons. Is this making a little bit of sense? So now we know a lot of things just from this picture. We know our explanatory variable, response variable, experimental units, factors, levels, treatments, and the amount per treatment. It's a lot of things. Okay, let's do another one. This one's about head lice. This one's one of the easier ones. It's kind of a bummer how easy it is. Did you guys know one lice is called a louse? I did not know that. So this is called a lousy situation. So funny. I get it. Thank you, Ivani. Thank you. So a study published compared 2 medicines to treat head lice. So there was a cream rinse called Nix and a comb out gel called Rid. Researchers studied 812 people in 376 households in 7 areas around the world. So these 812 people came from these households. Of the 185 randomly assigned to Nix, 171 were free from head lice after 2 weeks, compared to only 151 out of the 191 households randomly assigned to Rid. So explanatory variable is our head lice treatment. So what do I want to call that? Medication? Lice medication? So 1 factor. My response variable is the lice. Do we have lice or do we not have lice? Now, the experimental units are kind of tricky because they tell us 812 people participated, but then when they gave us the results, they gave results in terms of the households. So our experimental units are really the 376 households. Which would make sense because typically when somebody in a house gets lice, the chances that other people are going to get it are pretty high, which is why you got to wash all the bedding and all the things, and it's crazy. Okay, well now if we wanted to show factors, levels, treatment groups, all that stuff, it's really easy this time. We have one factor, it's the medication. It has two levels. One level is Nix, the other one is RID. This one has one small tweak because we didn't split our 376 households in half. For some reason, they were slightly different. So 185 were assigned Nix and 191 were assigned RID. And with just this one picture, I've been able to communicate that I know there's one factor with two levels, two treatment groups, and the number of subjects in each treatment group. Underneath, I am going to just write two treatment groups. You feeling kind of okay? Maybe a smidgeroo, smidgen. Okay, I want you to skip one and come back to it. This is one of the ones we're not going to do. And I want you to go to page 909 and just set up the explanatory variable, the response variable, and the experimental units. So take 1 minute, maybe a little more, to read the fabric science and just fill in the three things that there's space for. About 45. $30. About 20. $10. $5. Okay, explanatory variable. This time there are three factors. You have the type of roller, you have the cycle time, and you have the temperature. What we're going to measure is the finish of the fabric. So at the very beginning, it says a maker of fabric for clothing is setting up a new line to finish the raw fabric. So what we're checking the quality of is the finish of the fabric. And then lastly, our experimental units, I don't know. I know they're specimens of fabric, but I'm not sure how many, because all the problem told me was that there's 3 per treatment group. But I don't know how many treatment groups I have yet. So I'm going to wait to fill in the number of experimental units until I can draw the picture of the treatment groups. So this is the first one where we're seeing 3 factors, and this is as complicated as it gets. So when you have 3 factors, you got to build out your table slightly differently. I'm going to do like I did on all the other ones. I'm going to go with factor. I'm out of lead. I'm out of ink, family. And I'm going to use my first factor of rollers. So, factor, rollers, 2 levels. And this time, I'm going to split the levels out. So I'm going to go 1 over here and 1 over here. The ones to the left will be the metal roller. The ones to the right will be the natural roller. So I take my first factor and I split them apart, because now I'm going to build 2 separate tables. So the first part, is the top factor. So this is going to look slightly different. That is cycle time. How many levels did that have? 2. So sorry, I'm just adjusting a little bit so I can fit everything in. 2 levels. So I'm going to write those over here in this. I'm going to start a table. It was 30 minutes or 40 minutes. So over here, I'm going to do the same thing, 30 minutes or 40 minutes. Then our third factor is temperature, and it also had 2 levels. So 150 degrees or 175 degrees. So now I can see that there are 8 treatment groups. 8 treatment groups, and my 3 factors are shown. We have factor rollers, factor cycle time, factor temp. So 3 factors. When you read this set of treatments, just be careful that you know for the metal roller, you have one that's being timed at 30 minutes at 150 degrees, one at 40 minutes, 150, and so on. So this is all for metal rollers. This box is all for natural rollers. We know that within each treatment group is 3 specimens of fabric. So now I know up here where it says experimental units, working backward, I know that that now is 24 specimens of fabric. You do not have to draw these pictures. If you choose not to draw the pictures, you would list out the treatment groups like this. So you would have to say something like metal roller, comma, 30 degrees, comma, not 30, 30 minutes, comma, 150. And then you would need to say metal 30, 175. Metal 40, 150, metal 40, 175, which I personally think is a lot harder than just drawing the picture. Either one works though. You're okay? You do not have to do this if you draw the picture. You only have to do it that way if you don't. Okay, so let's have you guys try 3. So try 3, and it's not new. You've now seen one of every kind that you'll see. So decide how many factors, so on. In about 30 seconds, I'll show you what I have for just the 3 things, not the picture yet. Okay, there's my first 3 things. About 30 more seconds and I'll show you my picture. $20. about 10. Okay, there's my picture. So he was one of the simpler ones, one factor with 3 levels. So there's 3 treatment groups. I would like to do one more before we move on to the next lesson, and that's just the next problem, number 4. I'll flip over in just 1 second. About 10. Five. Okay, so last one of these that we're going to do together is improving response rate. So just like before, take 1 minute and try to fill in these 3 things. About 45. $30. About 20. 10. Okay, this time you have 2 factors. It's the intro that the caller gives and whether or not they will send the results of the survey. The response is whether or not the interview is completed. The experimental units, we don't know how many, but the randomly selected households that they called. So now try to build that table based off of those 2 factors. So roughly 45. About 30. $20. $10. $5. Okay, I have 6 treatment groups. So for the intro, she either gave the name, the university's name, or both. For the results, either she's going to send the results or she's not. Make sure that you feel good about what each box represents. So this would be the treatment group where she gives her name and offers to send the results. Gives the university's name, offers to send the results, gives both and offers to send the results. We're okay there? So all you have left to complete this portion is the internet telephone calls, and then you'll hop back and just do this number 1. So 5 and 1 is all you need to do to complete this now.